Alright guys, welcome to test 3 review. I'm going to go over these questions one at a time. I'll try to do my best to explain it as carefully and as thoroughly as I need to be. If you still don't understand or have more questions, always email me back, or I'll be in the Blackboard on Wednesdays, Monday and Wednesdays from 7 to 8 for you guys, okay? Okay, so question number 1 and question number 2 are asking us to do the same thing. So we'll go over question 1. It's asking us to take 24 base 5 and convert that into a number that we use every day, base 10. So like, how much is it worth base 10? So each of these digits, the 2 and the 4, has a different amount of worth. Okay, let's recall, as I know it's been a while, that in our tens numbers, like numbers we use every day, the first digit is the ones digit, which it basically means it's worth 1 point. So for example, if you have 123, you have 3 ones, you have 2 tens, and you have 1 100. That's how you do base 10. Well, the same is true for any other base, right? So you have 4 ones, right? That's 5 to the 0 power, which is 1. That's worth 1 point. You have 4 of those. You have 2, not tens, but 2 5s, okay? Because it's base 5. 5 to the 1 powers. So then if we have, so let's go back to the example of tens. 1, 2, 3. If we have 3 ones, you have 3 ones, plus you have 2 tens, plus 2 tens, plus you have 1 100, you have 1 of 100. If you add it up, you're going to get the same number, 123, right? So we're going to do the exact same thing with this problem for number 1. We have 4 ones, so that's 4 times 1. If you want to put 5 to the 0, you can, because 5 to the 0 is equal to 1. So understand it's 4 ones, plus you have 2, not 2 tens, but 2 5s, because this is worth 5 to the 1 power, not 10 to the 1. So we have 2 5s. Well, 4 times 1 is 4, 2 times 5 is 10, and if you add it up, you end up getting 14 points. It's worth, this value in tens, in the way we count every day, is 14. So the answer is C. That's the answer. Okay? Let's try number 2. It's the same type of question, different base. So I'll put the work here. Okay, I'll do it in a different color. So 31, excuse me. You have 3 digits, and it's base 4. So this is still the ones, okay? It's still the ones. 4 to the 0 power is still ones. So you have 1, I'll do this part here. You have 1 of 1 point. You have 1 ones. You have 3 of 4s. This is not 3 tens. This is 3 4s, or 4 to the 1 power. So you have 3 of 4s. Plus, now this would normally be hundreds, right? Because it's 10 squared. But in this case, it's 4 squares. It's going to be 2 16s or 2 4 squares. You guys remember that? So let me put that here. We have 2 of 4 squares. So how much is this worth? You have 1 of 1s. That's 1. You have 3 of 4s. You have 3 4s. So that's 12, because 3 times 4 is 12. And you have 2 4 squares. Well, 4 squared is 16, and you have 2 of them. So 2 times 16 is 32. And if you add them all together, you're going to get 1 plus 12 plus 32. What is that, 45? So that's our answer. The answer is D. That's how you go from one type of base into back to base 10. Question 3 is asking us to do something different. Question 3 is asking us to take a number that's already base 10 and to convert it into a different base 5 or whatever. So in this problem we see it says base 5. So we have to think about the digits of the 5s. Since we're converting to base 5, we got to think of it. This is going to be the 1s, right? This is going to be the 5s, 5 to the 1 powers. This is going to be the 5 squares. There's going to be the 5 cubed, etc. Right? Every digit, as you go further and further to the left, gets to have a higher power of 5, basically. Now, it's not worth the same as tens. Remember, this is the ones. This would have been the tens, the hundreds, the thousands. 5s are a little different. For 5, it's going to be the ones. This is worth 1 point. 5 to the 1 power, this is worth 5 points. This is worth 25 points. This is worth 125 points, etc. Now, we're not going to need to go any further because the number we're converting is 83. 83 is not, this is so small that we don't even need 125. This is too big. So we don't need this digit. But we do have 25. We can take away 25 from that. So this is one way I showed you guys in class. If you have 83, how many times can I take away 25? Well, I can take it away once. That's gonna, let's see, I'm gonna take a calculator out and I'm gonna see what it is. 83 minus 25 is 58. I can take it another time, take it twice, and I do that, another 25 away, and it gives me 33. It's still bigger than 25. We can take it a third time. You keep taking away 25 until you're left with a number less than 25. So it leaves me with 8. I took away 25 3 times. You guys see that? So that's where that 3 is going to be written here. It's going to be 3 here because I took away 25 3 times from 83. Now with 8 remaining, how many 5s can I take away? Well, let's see. I have 8 remaining. I can take away 5 once, and what's remaining is 3. That's already smaller than 5, so I can't take any more away. I can only take 1 5 out of the remaining 8. Now I have 3 left. And the final number are how many 1s you have left. You have 3 1s left, so that's going to be 3 here. So the answer for 3 is B. 313 base 5 is the same value as 83. Okay, the answer is going to be B. All right, number 4. Number 4 and 5 are both asking us to plug in numbers into the expression and to evaluate what the answer is. Okay, so for number 4, we're only expected to plug in. There's only one variable, so the equation is 6 times x minus 4. That's the equation. This part is what x is going to become when I plug it in. So what am I going to replace x with? According to the problem, I want to replace it with -1. So instead of saying x, I'm going to say -6 times -1 minus 4. And then we just evaluate. What is -6 times -1? Positive 6. And then this minus 4 is still there. And what is 6 minus 4? 2. The answer is 2, so B is the answer. So far so good, right? For number 5, we're going to do exactly the same thing, but it's a little more complicated because it's a more lengthy equation, and it has 2 variables now you have to plug in, not just 1. So let's go ahead and write the equation. 3x squared minus 8 times x times y minus 2 times y squared. X is going to be -5, and then y is going to be -6. So every time I see an x, like right here, I'm going to put -5 and then square it. Don't do this, please. Make sure you're plugging in, so you have to put parentheses around it, okay? Minus 8 times x. X is -5. And now I see a y now. What was y again? Y is -6. And then minus 2 times y squared, which is -6 squared. So definitely, you have to be careful and make sure you put your parentheses correctly when you do this one. Now we're going to evaluate, term by term. So we're going to work with this one first. I'll get a different color. How's this color? So before I worry about the 3 and the -5, I have to worry about this exponent first. This has to be evaluated. PEMDAS is parentheses, which technically there's nothing inside the parentheses except one number, so we don't have to worry about it. Then exponents. Exponents is next in that list. So we have to do -5 squared. Common mistake people make. They put in their calculator -5 squared like this, and the calculator tells them -25, which is true. That is -25. But you're squaring 5 when you write this in your calculator. You're supposed to square -5. So it's very important you put in your calculator -5 in parentheses squared, okay? So -5 squared is actually positive 25. And now we can multiply the 3 and the 20. Let me write this better. And now we can multiply the 3 times 25, which is 75. We're done with this term. Let's do the next one. So this one says 8 times -5 times -6. We're going to bring down the minus, right? Now 8 times -5 times, oh, I need a calculator for that one for sure. So 8 times -5 times -6 gives me 240. So I multiply these 3 numbers from left to right. That negative sign, I just brought it down. So I just did 8 times -5 times -6. It gave me 240. That negative carried down. It's still there. So the answer is 240. Got this one done. Now this one is similar to what we did a second ago. I'm going to bring down the negative, and then I'm going to worry about the 2 times negative 6 squared. So negative 6 to the second power is 36, positive 36, don't forget that. And 2 times 36 would be 72. That negative, again, I just brought it down, no big deal. And now we, again, use a calculator, and we put 75 minus 240 minus 72, and the answer I get is negative 237. This looks a little sloppy, write it again. And boom, that's our answer. Answer is C. Simple, right? Not too bad. This is a little more time consuming, but not that bad. All right, number 6. Number 6 is asking us to do the same thing again. So we're going to plug in x and y, but the equation's a little bit easier, I think, than what we just did in number 5. So let's see. So I'm going to write the equation over before I do it, okay? Now, I'm going to plug in into the x 3. So it's going to say 3 plus, and then 2 times y. Y is 2. So I replace 2 with another, y with 2. And then that's the problem. Don't do the exponent yet. PEMDA starts with the parentheses, then exponent. So if there's anything inside the parentheses, like this one has stuff inside, you got to figure out what's inside first, what it becomes. So 2 times 2 is 4. Remember, we have to multiply first. And then we add. What's 3 plus 4? 7. Now we're able to square. So 7 squared is 49. Perfect. We got the answer as B. Easy. So for number 7 and for number 8, all you're asked to do is to simplify. You're not asked to solve. You're not asked to do anything except to just combine like terms or distributive property or whatever you need to do to simplify. So for number 7, here we're going to combine like terms. There's it's all about, so for example, 7z plus 1 minus 2z plus 9. Can we write this with fewer terms? The answer is of course we can, because we're using too many terms. We're repeating the same term again and again. So like, for example, this 7z can be combined with this negative 2z. So then how do you combine them? Well, you just add them or subtract them, whatever, as you see it. So 7z minus 2z is just basically 7 minus 2. Okay, that's 5z. And then you have another pair of like terms, the positive 9 here and this positive 1 there. So positive 9 or positive 1, whichever I'm going to start with first, doesn't matter. 1 plus 9, that's 10. Boom. 5z plus 10 is the answer for 7. The answer is A. Negative 8. Okay, so I hope you guys remember how to do this. This is known as the distributive property. Whenever you have a parenthesis and something next to it, it's asking you to multiply whatever is outside to each term inside the parentheses. So negative 4 times x is negative 4x. Negative 4 times y is negative 4y. And you're done. You don't do anything else. So let's see. A is not it because it's plus. B is wrong. C. There you go. C is the answer. Alrighty. Now this is going to be the most questions in the test will be solving for x. If you notice, there's like 10 of them, I think. So we're going to start with number 9. We're going to solve for x. Here we go. To solve for x, I'm going to write the equation over. You have to isolate the variable. You have to remove any obstacle that prevents x from being alone or isolated. And if you look at this problem, the issue is the minus 15 here. So you got to get rid of the minus 15. Now how do you do that? Well, in algebra, to get rid of anything, you always reverse its operation, or you would call an inverse operation. So if you're taking away 15 from x and you want to reverse that, you're going to then, instead of taking it away, you're going to add 15 to x. But whatever you do to one side, you must do to the other. Okay, it's a golden rule of algebra. So now the 15s cancel, and there's no longer anything there bothering the x. And then we just combine these two. Negative 4 plus 15 is 11. And that's our answer. We're done. We isolated the x. X is alone. And now we know what x is equal to. It equals to 11. The answer is A. Alrighty. Number 10 is same idea. Okay. We're going to solve for x by isolating that variable. Now x is being divided by 3. So how do you reverse a division? What's the inverse operation? What's the opposite of dividing? And a lot of you guys already said it. It's multiplying. So whatever I do to one side, I do to the other. Some students ask me, why do you multiply by 3? Because I need to get rid of this 3. This is the 3 that's bothering me. So the only way to get rid of a 3 that's being divided is to multiply by 3. So 3 is not arbitrary. 3 is deliberately multiplied to cancel this 3 out. Now whatever I do to one side, I do to the other. So let's pretend that my question was like this. Some students say, why can't I just multiply by 10? If I multiply by 10 to both sides, does the 3 get canceled? No, it doesn't. The 3 is still there. In fact, you're making it more complicated. Now, x has a 10 next to it. The whole point is to get rid of any number and leave x alone. So, you have to be careful there. Anyhow, x equals to 13 times 3. That's 39. So the answer is C. Awesome. Awesome. All right. 11. 11 is asking us to solve for this equation. What is it? Negative 7x equals 14. So we have to look at the x and say, okay, what's happening here? Well, x has two things going on. Oh, sorry, one thing going on. It's multiplying. And what's it multiplying with? A negative 7. So this negative 7 that's multiplying needs to go away. So how do you get rid of a multiplication? How do you reverse that? How do you undo it? Well, the opposite of multiplying is division. So we're going to divide both sides by the number we're trying to get rid of. We want to get rid of the negative 7, right? So we have to divide by negative 7. And that's why they cancel. And then you're left with x since it's gone. There's nothing left but x. And then 14 divided by negative 7, negative 2. And you're done. The answer for 11 is D. See how easy this was? Let's look at 12. So 12 is known as a two-step equation because you have to do this in 2 steps. It's not as quick and easy as the number 10 or 11. So there are two things that are menacing the x variable. You can see that x is being multiplied by 7 and also being subtracted by 4. So you have to get rid of both. The question is, does it matter the order in which I get rid of it? And the answer is yes, it does. You never want to multiply or divide right away to get rid of something next to the x. The reason why is because whatever you multiply, you have to multiply to everything. And the 7 is only multiplying to the x, not to the 4. So it doesn't make any sense for me to divide 7 and 4 by 7. That wouldn't make any sense at all. So don't do that. In other words, get rid of that negative 4 first, okay? And that's always the step. You get rid of the adding subtracting first, and then you divide or multiply. So we're going to get rid of the negative 4 by adding 4 to both sides. And when we do that, we're going to get 7x equals to 66 plus 4, which is 70. And now we can ask, how do I get rid of 7? And that 7 is dealt with easily by dividing both sides by 7. Right, just canceling it out. So x equals to 70 divided by 7, which is 10. And you're done. And the answer is C. Simple. Alrighty, 13. To do 13, you have to get rid of parentheses. Now, you gotta be careful, because this parentheses is not just any parentheses, nothing next to it, but it actually has a number next to it. It's not written, but it's a negative 1. That's actually a negative 1. That's multiplying to this expression, 5x minus 1. So the only way to get rid of the parentheses like that when it's being multiplied by a number is to distribute. Okay, we did an example like that earlier. So we're going to distribute the negative 1. So 6x is still there, nothing's wrong with 6x. But now, negative 1 times 5x would be minus 5x. Negative 1 times negative 1 is now a positive 1. Look how it changes everything. And then it's still equal to 2. Now we're going to combine like terms. I've noticed that 6x and 5x can be combined because they're common terms. So 6x's minus 5 of them, you're just left with 1x, right? Plus 1 equals 2. And now we can get rid of that plus 1 by subtracting 1 both sides. And boom, I'll put the answer here. X equals to 2 minus 1, which is 1. The answer should be A. Simple enough, right? I'm going to do 14 here because I'm running out of space. So it's going to be a more complicated question. 2y minus 5 equals 7, y plus 4. Okay, so how do I solve for x? Well, before you can solve for x, or sorry, not y, x, y, they changed the letter. How do I solve for y? In order to solve for any variable, whatever it's x or y, whatever letter they want to use in the alphabet, you have to get rid of parentheses. You have to make sure that there's no parentheses anywhere. It's very important that parentheses go away, because parentheses groups things. And to solve for x, you need to isolate it, which means you have to ungroup things, right? So how do you ungroup or get rid of that parentheses? You're going to distribute. So the 4 is going to distribute. At 7 is going to distribute too. So you have two different cases where you're going to have to distribute a number. Let's do the first one. 4 times 2y is 8y, because you just multiply 4 times 2. 4 times negative 5 is negative 20. And then we're going to multiply 7 times y, 7y. And then finally 7 times 4, that's positive 28. Now, we're almost, we're able to put the x's to one side and constants to the other. So now we're able to do that. So we're not done yet, but we've gone more than halfway there, okay? So to get rid of, or at least to isolate the x's, or the y, excuse me, you have to make sure they're at least on the same side. This positive 7y needs to go to the left side. Okay, so how do you do that? Well, let's suppose you were to subtract both sides by 7y. What would happen? Well, 7y minus 7y would cancel out, so the 7y is no longer there. And then when I subtract whatever I do to one side of the equation, I do to the other. When I subtract 7y from 8y, I'm just left with y left. And look, so far, we're almost done. We have one more step to go. Now the y is being harassed by that negative 20, that minus 20 there. So we're going to get rid of that minus 20. And the only way to do it is by doing the inverse operation, which is to add 20. Whatever you do to one side, you do to the other. Boom, it cancels out. And now you're left with finally the y. So you isolated it. And what's left over on the other side? 48. And that's your answer, 48. So the answer is C. 48. Okay, so to do number 15, I'll just work it out here. So I'm going to just copy it over. 4 times 5x plus 3 times 2x minus 2 equals to 5x plus 90. Okay, now to do this one, we have to make sure we get rid of those parentheses. Like I said before, I just said it a little while ago, you can't isolate x's if there's groups around. And to isolate things, you have to ungroup things, right? So to ungroup it, we're going to distribute the 4 in the first parentheses and the 3 in the second one. So now 4 times 5, that's 20x. 4 times 3 is positive 12. Plus, now 3 times 2x is 6x. And 3 times negative 2 is negative 6. Alrighty, so the right side had no parentheses, so it was okay. Now we're going to combine terms, combine like terms. So I noticed that the 20x here and this 6x can be combined. So what is 20x plus 6 more x's? 26x. Excellent. I also noticed that the 12 and the negative 6 can be combined. So what is 12 minus 6? That's 6 remaining. Okay. And now we're able to start moving things around, right? This is the part where we have to move the 5x, for example, on the right side. This 5x here, I got to get rid of it. I want to move it to the left side. So the only way to do that is by subtracting 5x. Whatever I do to one side, I do it to the other. Okay, so now it's going to cancel out. And just to save a little bit of space here, I'm going to go ahead and subtract the 6 at the same time. So the 6 is going to be, what that's adding, it's going to be subtracted to go away. But whatever I do to one side, I do to the other. Now that goes away. So let's see what we have left over. We have 26x minus 5x, that's 21x. And we have 90 minus 6, that's 84. So I'm going to continue over here. 21x equals 84. So what's the next step? How do I solve for x? What do I have to do? Well, if you said we're going to divide, you're correct. So we're going to go ahead and divide 21 both sides. Now why 21? Because 21 is multiplying to the x, that's why. So look how it cancels away. And now we're left with 84 divided by 21, which it's 4, I believe. I'm almost certain it's 4. Look at the choices, right? So the answer has to be D. Alrighty. Number 16. Now this is admittedly a little difficult. Okay, it is, but it's not that bad because you can get rid of those fractions. Okay, I know you have fractions all around, but they don't have to stay there. They're not permanent. They're there for now. We can undo that. So how do we do this? Okay, let's find out. X over 2 plus x over 5 equals 7 over 2. Let me make this a little bit neater. Over 5, 7 over 2. Okay, now in order for me to even start this, I have to make sure that the denominators go away. At least in these cases, right? We're not trying to add fractions, we're trying to solve for x. So we want to get rid of those denominators. So the question is, what do I have to do to get rid of those denominators? Well, the simplest way is let's try to determine what the least common denominator is, and whatever that number is, we're going to multiply it across the entire equation. You'll see now what I mean. So the denominators are only two types of numbers. There's 2 and 5. So if I were to look at the times tables, or we call the multiples of 2, it's 2, 4, 6, 8, 10, 12, 14, etc. Correct? And then for 5, it's going to be 5, 10, 15, 20, etc. So it goes on forever, obviously. The question is, what's the least common multiple between 2 and 5? Well, let's see. 2, 4, 6, 8, 10 is the first time they match. That least common multiple, that's what I'm going to do. I'm going to multiply everything by that least common multiple. And look what happens. 10 times a fraction, all you got to do is just multiply 10 times x. You don't have to multiply 10 times 2. You're not multiplying by 10 over 10. We're multiplying by 10. So the 10 only gets multiplied to the numerator, okay? So 10 times x is, I guess I'll make this parentheses a little smaller. So 10 times x is 10x over 2 plus 10 times x again is 10x over 5 equals 10 times 7. Remember, the entire equation gets times 10. It's like if I double everybody's salary or something, and I just multiply everybody by 10. That's fine as long as you do it to everything, okay? So 10 times 7 is 70 over 2. Now we're going to simplify this. Now, what's 10 divided by 2? 5, right? So this is the same thing as saying 5x. What's 10 divided by 5? Isn't that it's possible to simplify? Yes, 10 divided by 5 is 2x. And what's 70 divided by 2? That's 35. Excellent. So now we have an equation. I'll write the equation here. 5x plus 2x equals 35. So let's go ahead and start solving. So before I do that, I noticed there's x's all scattered around. So I got to combine the like terms. 5x and 2x can be combined. 5x plus 2x is 7x. And that equals still to 35. And now we can divide by 7, not by 35. We're going to divide by 7 now. Why do we divide again? To get rid of the 7. The 7 is what's troubling us. It's not the 35, it's the 7. So we're going to cancel the 7. And now it's going to be x equals to 35 divided by 7, which is 5. So the answer is 5. The answer is choice D. Excellent. Simple, right? Alrighty. Number 17 is asking us to solve for x, but it's in the proportion format. What that means is you have two fractions equal to each other. Whenever you get two fractions, and only two fractions equal to each other, you don't have a situation like this where it's like plus 1, where now that changes everything, right? We only have two fractions equal to each other. So we do not have to get the mentality of, I got to get rid of the denominators. You don't have to do that. Whenever you have only two fractions equal to each other, we call that proportion. This is what we would call a proportion, right? The way you solve is by cross multiplying. It's that simple. Excuse me. So I'm going to multiply 2 times x. And what's 2 times x? 2x. Then I'm going to put the equal sign because I already multiplied one diagonal pair. Now I'm going to multiply the other. After I put the equal sign, now I multiply the other pair. What's 5 times 3? Well, the answer is 15, right? 5 times 3 is 15. And we're now got rid of the fractions. It's no longer there. Now, this strategy only works for proportions. It does not work for any other cases, okay? Cross multiply only works for proportions. So, and believe it or not, number 18 is a proportion. Don't think it's not, but we'll get to that in a moment. Anyhow, so we're going to go ahead and solve for x by dividing both sides by 2. Since we got to get rid of that 2. So x equals to 15 divided by 2. Now, I don't know. That doesn't equal to a whole number. But if I look at the choices, 15 over 2 is definitely one of the answers. So we don't have to actually divide it. Okay? A second ago, I told you that cross multiplication is the way to go in solving for x when you have proportions. And the proportions, we have a fraction equals to another fraction. And that's it. Even if the fractions are very complicated, like the ones we're about to do, this one, it's still a fraction. I don't see anything else except one fraction there. Yes, it's a complicated one, but it's still just a fraction. Same is true for the right side. Now, that's an easy typical fraction. So how do we solve for our x? Well, we do the same strategy. We're going to cross multiply, okay? So I always do the diagonal. It doesn't matter which diagonal pair you start with, but I always start with the one that has the variable. So I'm starting with this one, okay? The one I'm just making bolder. So x minus 7 times 5, or I'm going to write like this, 5 times x minus 7 equal. Now we multiply one diagonal. I now put equal, and then I multiply the other diagonal. 2 times 1. That's easy. That's 2. Now it looks much easier. It looks much more simpler. So we're going to go ahead and distribute that 5, right? We got to get rid of that parentheses. We have a group. We have to solve for x. We got to isolate groups. So we're going to distribute the 5. 5x. 5 times x is 5x. 5 times 7 is 35. So it's minus 35 equals 2. And then to solve for x, we got to get rid of first the 35. Remember, get rid of the plus or minuses first. So the 35 goes. We add 35 to both sides. Excellent. And now we're going to get 5x equals to 37. And there's one more step to go. To get rid of that x, the 5 to find x, you have to divide by 5. Boom. I divide both sides by 5. X equals 30. Let me write this a little neater. 37 over 5. Is that choice here? Yes, it is. It's B. Simple. Alrighty. We're almost there. So number 19 is also, something we did in class. It's an equality instead of an equation. And the reason why it's not an equation is because it doesn't have an equal sign, right? It has a less than sign. So, but it's the same idea. We're still going to solve it like normal, okay? The question is, how do I solve for x? Forget for a moment that this is less than, okay? Pretend that was an equal if you need to. How do you solve for x? Wouldn't you get rid of the negative 2? Well, yeah. Now that negative 2 is not being multiplied, so don't divide. It says x minus 2, so you have to get rid of a minus 2 by adding to both sides. We're going to cancel that out. We're going to get x is still less than. We're going to bring that inequality down. We're not going to mess with that yet. Negative 6 plus 2, which is negative 4. And you're done. So the answer is x is less than negative 4. Now, I know you see the graph, but you don't really need to worry about that because the choices are all different. So the answer is x is less than negative 4c. You guys see that? The graph, if you know how to do it, that's even better. But if you don't, it's not really required. It is multiple choice. Alrighty. The next one. Negative 4x is greater than or equal to 36. Okay. So imagine for one moment that this is not an equality. It said equal. Wouldn't you get rid of that negative 4 by dividing both sides by negative 4? Then that's still the same step. Nothing's changed here, okay? We're not going to not do that step. But there is one slight difference between equations and inequalities. If you divide by a negative, okay, if you divide or technically multiply by a negative number, then you must rotate the inequality, okay? Remember the last class we had together, I spent a good amount of time explaining why. But for now, we're just going to remember that it does rotate. So it's going to say x negative. Okay, so 36 divided by negative 4 is negative 9. But this symbol does not stay greater than or equal to. It's actually going to rotate and become less than or equal to. And now we got the right answer. So let's see. And it's negative 9, by the way. So I see A. I saw less than. I saw 9. I said, oh, it's 8. But no, it's not, because it's positive and it's supposed to be negative. So it's not A, it's not B. So between C and D, it's going to be C. A lot of people might pick D because they forgot to rotate the inequality. Please don't make that mistake, guys. Okay? You should know better. Alrighty. We have 2 more to go. So to do number 21, again, I'm going to write the problem here. 8x plus 4 is less than 9. X minus 6. We're going to solve for x. Again, solving for x requires us to isolate things, to ungroup things, right? So that 9 needs to go into that parentheses to get rid of the parentheses. So we're not even ready yet to even become close to solving. So 9 times x is 9x. 9 times negative 6 is negative 54. And now we're ready to start shifting things around, or shuffling them around, moving one thing to the other side, etc. So, how do I do that? Well, that 9x is positive. I'm going to subtract 9x both sides to get rid of it. And then if I do that, now the x's are now all on the left side. That plus 4, by the way, that's also on the left side. I got to get rid of it. I don't want to have variables mixed with numbers. I got to get rid of the numbers. So that plus 4 is going to go away by subtracting 4 both sides. That's how that's going to go away. So we're going to end up with, let's see, 8 minus 9x is negative x. We're going to keep this inequality. We haven't multiplied or divided anything, so we're going to leave it alone. We're going to leave this completely alone until we finally multiply or divide. If it's negative, then we flip it. If it wasn't negative, then we don't have to worry about it. The last step. Okay, so negative 54 minus 4 is negative 58. Okay, one more step to go. So we have to get rid of that negative next to the x. Now I know we don't write it normally because 8 minus 9 is technically negative 1. We just put negative. But there is a 1 there. So now you know what to do. You divide by negative 1 both sides. Now, x is going to now become positive, right? And this negative 58 divided by negative 1 becomes positive 58 as well. However, what happens with the inequality? It's going to rotate. And I think you guys know why. We just divided by a negative. So this inequality is now going to rotate entirely. And that's the answer. X is greater than 58. The answer is B. So B is our answer. All right, and we have one more to go. This is number 22. And let's see if you guys, at this point, if you got everything up to this point, you're going to get an easy 110%. Okay, so let's go. We're going to go ahead and say 9 minus, I'm going to write it over, 8x plus 2 less than 3, 2x minus 4x. Sorry, 2 minus 4x, excuse me, I read it wrong. We're going to get rid of that. Okay, so here is a tricky one. I want to make sure we pay attention to this, okay? We're going to distribute this, but what's multiplying to this parentheses is not strictly just an 8. It's a negative 8. So when I bring down the 9, that stays positive. But the negative 8 times x becomes negative 8x. Easy. But then negative 8 times positive 2 is now negative 16. The most common mistake people make is they put x, 8 times x. They'll correctly put negative 8x because the negative's there. But then they'll put plus 16 because they'll forget that the negative 8 is being multiplied, not an 8. The right side is quite simple. It's just 3 times 2 and then 3 times negative 4x. So it's 12x. And now, before I actually move things to one side to the other, I'm going to combine like terms. I notice that this positive 9 and this minus 16 is on the same side. So let's put them together. Let's see. Negative 8x is still by itself. It's the only variable there. It's not a big deal. And then we're going to have 9 minus 16, which is negative 7. Okay. And now we're ready to shift things around left and right. Okay. Let's shuffle it around. So let's see. If I want to take this x over here, this negative 12x, and move it to this side, I'm going to have to add both sides 12x. When I do that, this negative 12x goes away, cancels out from the right side, and now ends up in the left side. Also, this negative 7 there, I gotta get rid of it. I can't have the x's mixed with numbers. So to get rid of it, I add 7. It cancels out, right? When you have a negative 7 and you add it, it goes away. Whatever I do to one side, I do to the other. So I add it to the 6. I now have, let's see, negative 8 plus 12, that's 4x. This inequality does not change. All right, and 6 plus 7, what is that, 13, I believe? So now we're almost there. We have one more step. We have to get rid of that 4 that's multiplying by dividing. And whatever I divide by one side, I divide to the other. So the answer is going to be 13 over 4, but it's still less than. Notice I didn't have to change the inequality because I never divided by a negative or multiplied. So I didn't have to rotate it or flip it, whatever. Let's see which is the answer. The answer is A. Let me see. No, I take it back. It's less than. So it's not A. A is greater than. So it's not A. It's B. Gotta be careful. I almost fell for that trap. The answer is B. Okay. And that's it. That's test 3. And I hope you guys, oh, and if you guys wanted to see the solutions, there it is. And I'll upload this to you guys now in a moment. So I do hope and I'm looking forward for you guys to get 110%, everybody. If you still have any questions on anything here, and you want me to explain through email, I'll be happy to respond right away. If you do want me to answer questions directly, I'll be available at 7 o'clock at that chat room. I'll send a link, and hopefully all your questions will be answered, so that way you guys can do perfect in this test. All right. Also, I'll have this test available now, not now, but before tonight, so you guys can start as soon as you can. Okay, and good luck. I'm rooting for you. And again, I know I'm dragging on here, but thank you guys for this, because you guys have been great sports. So thank you so much for all your patience and everything. You guys have been very, very good about this. So again, I appreciate all the your input on this. Okay. All right, guys. Take care.